This is a brief introduction to quantitative designs. Now remember, quantitative research is a broad category of research where we're answering questions that have a concrete or measurable answer. So the key with quantitative designs is depending on the type of concrete answer we want and the type of concrete question we're asking, we need to design a study that can answer that specific type of question. So for example, if I asked you, what's the temperature outside? You would answer my question by taking a thermometer maybe and going outside and seeing the current temperature is 91 degrees Fahrenheit. So you'd come in and tell me it's 91. You answered my question. However, if I asked you, are you more sleepy in the morning or the evening? You couldn't really answer that with a thermometer, but you might create a little scale, a sleepiness scale from 0 to 10. How sleepy are you? And you could fill that out at 8 a.m. and then at 8 p.m. and compare and then tell me and answer my question. Now, this isn't research, and you can probably already see some potential flaws with how I chose to answer these questions, but notice that depending on the question we're asking, we collect different types of data with different instruments, so maybe a thermometer or a sleepiness scale, in different ways. So maybe just one time, or maybe before and after, or maybe at two different points in time. Now, these different ways of answering different types of questions are the many different designs. So when is quantitative research appropriate? Well, quantitative research examines relationships between and among variables. So remember, variables are those things or concepts that can vary, either between or among people. So things like blood pressure, zip code, amount of physical activity, height, weight, ethnicity, stress level, income, education level, perceived social support. These are all things that we can attempt to measure that can vary between or among people. So quantitative research is asking questions about predictions, descriptions, and or correlations in specific variables. And it's the question or questions about those variables that's really going to guide the rest of the study. Now, quantitative questions can be asking about whether one variable predicts another variable. So for example, does engaging in physical activity predict or cause a reduction in stress level? Or a quantitative question can just aim to describe a sample. So what's the average blood pressure in this group of people? A quantitative question can also be asking if there are relationships or correlations between variables. So for example, as income levels decrease, do stress levels also tend to increase? So when questions like these are asked, we're asking quantitative questions that are best answered by quantitative research designs. Now, the rest of this presentation will focus on some general points about quantitative designs. So we'll expand on that a little bit later, but it's also important to understand some really basic terminology here. So looking at sample. In nursing research, the sample most often includes people, and these can be patients, nurses, other healthcare providers, families, etc. But the sample, those people we recruit to come and participate in our study, they should be representative of a target population that we're interested in. So for example, if I'm asking, what's the average stress level of nursing students in the United States? That's the question I have that I want to answer. I better include a sample that's really similar to the entire U.S. nursing student population. Wow, this could be really tough. I need to consider ethnicity, income level, geographic area, age, etc. So does my sample need to include the entire nursing student population? No, that's basically impossible. However, I need to consider if the people I've recruited to participate in my study, my sample, I need to see if they really represent the actual nursing student population pretty well. So keep in mind, the sample is the group of people that are participating in the specific study, and the population, often referred to as the target population, well, that's just that, the broader population that we're trying to learn about, that we have a question about. And it may not be completely accessible to us. Now, another key vocabulary word to understand, and that students a lot of times kind of struggle with this, is measures. And sometimes this is referred to as outcomes. This is similar to when I asked you if you're sleepier in the morning or sleepier in the evening. And you could answer me by measuring your sleepiness. And you operationalized sleepiness, or you interpreted and identified what that variable is and how it could actually be measured in real life. You operationalized that variable by creating this sleepiness scale. So the measure or the outcome is sleepiness, and the instrument or the tool is how I measured sleepiness with that sleepiness scale, that specific thing you use to get me that information in a more concrete way. So, what are the different types of quantitative questions we can ask, and what designs can answer those types of questions? Well, there are a lot of ways we can divide up quantitative research into categories, and one of the simplest and broadest ways to divide it up is into non experimental, experimental or quasi experimental, and meta analysis. So, very broadly, when we say non experimental, we are talking about, well, just that, not doing an experiment, meaning we're not going to do anything to our participants to see if something happens when we do that thing to them. We aren't and we can't look for cause and effect. And this is really important to understand. So, what kind of research would this be? Well, think about a lot of epidemiological research. For instance, what's the prevalence of diabetes? What's the prevalence of diabetes in persons living below the poverty line compared to those living with at twice the poverty line? Did I do anything to these people? No, I just want to describe them in detail. So non-experimental quantitative research can describe the sample in a lot of different ways. Maybe I'm just going to describe the characteristics of a sample. So disease processes, ethnicity, income, zip code, education level. A lot of our demographics go here. Maybe I want to describe them in how much stress they experience. So I would give a bunch of people in my study, the sample in my study, this stress level survey and compute the average stress level for the participants in my study. I'm describing them again. Or maybe now I want to see a little bit more detail. I want to see if there's a relationship or correlation where I wonder if people living in a specific zip code have an average lower stress level. Or maybe people with lower levels of education, do they have a higher stress level? Again, did I do anything to them? No, I gave them a survey, but that survey was my data collection, and I didn't expect that survey to do anything to them. I'm just gathering information about the sample. I'm not doing an intervention. Now, keep in mind that non-experimental research includes a lot of designs within it. So this is a category of quantitative designs. So you'll not likely see a researcher describe their study as non-experimental. That's way too broad. Rather, they might describe it as cross-sectional or descriptive correlational. And these are those more specific designs within non-experimental research. So we've talked about non-experimental designs where we're describing a sample and maybe some relationships between variables in that sample. Now let's move to experimental or quasi-experimental designs. Now this one's a little more obvious. We are doing some kind of experiment. So regardless, studies in this broader category involve us doing something to or seeing the effects of an intervention. And that's often your keyword is intervention. That's how you know you've got some kind of experimental or quasi-experimental study. And when we're looking at intervention research or experimental or quasi-experimental designs, we're looking at the effect of one variable on another variable. So these are called the independent and dependent variables. And the independent variable is the intervention or the thing we manipulate. So think independent and intervention both start with an I. That's one way to memorize that. And then the dependent variable is the outcome. The variable that we want to see, is it affected by that intervention? And I often think of this as, is that variable dependent on something, or is it affected by that something, that independent variable? So in experimental and quasi-experimental research, we want to assess whether our IV, independent variable, affects the DV, the dependent variable. So we manipulate, or we decide who gets what and how they get it. We manipulate that independent variable as the researchers. So more often than not, we want to see if an intervention or an independent variable improves something, right? That's why we're doing this study. We want to see if we can help people. So for example, let's say I have a bunch of participants in my sample with this study on hypertension, and I find out they're not very good at taking their medication as prescribed. So I design a study, I design a quasi-experimental study, and I create an intervention, and it's a smartphone app that sends them reminders every morning or whenever they're supposed to get their medications. Take your meds. I did something to them. I signed them up for this app, and I'm going to measure the effects of this app on whether or not they take their medications as prescribed. So when you're wanting to see the effects of something that we do to a group, you're looking at experimental research. Now back to that example of the smartphone app, what if just being in a study makes all participants take their medications more regularly, right? They're being watched, so they're going to behave themselves. How do I know if the results of my study are positive? How do I know if it was the app that I created or just being in the study that made them take their medications as prescribed? Well, I can't really know. unless I have a control or a comparison group. So I could have a whole other group of participants who are in my study, and all they do is have their medication compliance measured at the start of the study, and then we measure it again at 3 months later at the end of my study. I didn't do anything to them, but they're still in my study. So then I compare their medication compliance to my other group, the intervention group. And those guys actually used my mobile phone app. And I measure this intervention group's medication compliance at the start of the study and then 3 months after as well. So now you can see I can compare both groups, and maybe both groups improved in their medication compliance, but the intervention group, maybe they improved dramatically more, and I can see that my mobile app worked. Now, one more category of quantitative research designs is meta-analysis. And meta-analysis is considered secondary research. It's frankly a lot of work, though. So in a meta-analysis, a team of researchers, again, are asking a quantitative question. But rather than answering this question with one single study where they collect a sample, they have a sample and they collect data on that sample, and then they analyze the results from that sample, they actually look up all of the past studies that have been done on that very specific question. And then they analyze all of the results of all of those studies as a group. So for example, maybe 20 other research teams have gone and done the same smartphone app medication compliance study that I wanted to do. I would need to make sure that all 20 of those research teams used the same smartphone app. They studied this in a similar way. They measured medication compliance in a similar way. They analyzed their data in the same way. Then in a meta-analysis, I essentially pool all of that information from all those studies and analyze all these studies about the same topic together. So you can see how maybe the results of one study could show me very valuable information, but really analyzing the results of many similar studies could provide me with even more rich and valuable data to answer that question. Does my smartphone app really work to improve medication compliance? When we ask these questions, does X affect Y? What is the prevalence of X and Y? Or do X and Y have a relationship or a correlation? We need to measure X and Y. So how do I get that information? Well, we call it data collection. When we measure something, we collect data. And we can collect data in a lot of different ways. Anything from having participants fill out a survey or taking participant blood pressure or heart rate, which is collecting data straight from the participants in a study. Or I can actually not have these participants filling out surveys or letting me check their blood pressure, and instead I go into the electronic health record. And maybe I pull information from there. Maybe I get some demographic or public health record data. So these are the broad types of data that can be collected, but we also need to think about when and how we collect this data. So if I ask, does guided imagery affect heart rate? I need to collect data on heart rate. I need to take a pulse of my patients or of my participants. So I might do what's called a within groups data collection, where I take my participants' heart rate at the start, then I have them do guided imagery, and then I measure their heart rate again. This is one way of collecting data within groups. Or maybe I want to see if nursing students and chemistry students have different average heart rates. So this would be called between groups. Think I want to see the difference between these two groups. And then keep in mind we can combine types of data collection. So data might just be collected once or at a single point in time, and this is often called cross-sectional research, where it's just one cross-section. Or we can gather data multiple times, like at baseline or the start of the study, and then at 1 month and 3 months and then a year. Or we can even do time series, where data is collected even more times than repeated measures. So this would be maybe even 20 times, where we collect data at 20 different time points. All right, so you've seen a brief overview of specific quantitative designs, but it's important to ask ourselves, when is quantitative research just not a good choice for the question we're asking? Well, if we think back to the beginning of this presentation where I asked you what the temperature was outside, that was a quantitative question and appropriate to answer with quantitative data. However, what if I wanted to know, what do you think of the weather outside? Can you really answer that with a thermometer? So this gets at the issue of when is quantitative research not the best choice. And in the cases we'll discuss here, we're talking about when qualitative designs are more appropriate than quantitative. So here you can see some examples. What if we know very little about a phenomenon? If we're embarking on brand new territory, we don't just want to jump in and measure blood pressure or cortisol level. we're limiting ourselves in a sense. We need to do some more exploring first. And if we jump into quantitative research too soon in some cases, we may find out that it wasn't blood pressure or cortisol that we should have measured. So what if we also wanted to learn about people's experiences or their stories? What's it like for someone living in a human experience? Can you really capture that with height and weight? Or even a detailed survey where you're forcing people to check boxes. Human beings can't be drilled down into numbers or demographics or really any kind of concrete data. Stories are really important in deeply understanding what human beings are going through. So you can see, if I wanted to really understand what challenges BSN students are facing, I need to talk to them. I could force them to pick some options on a survey that I think might be relevant, but think about how much richer the answers would be if I just asked these students, tell me what it's like to be a BSN student. What challenges have you faced? And let them talk. And then analyze that data. Next, if we want to understand meanings of concepts or phenomena, this requires talking to people again and gathering qualitative data, hearing how they describe something and then analyzing those words. So for example, let's say women in southern Louisiana report that they have great health. But when we look at the statistics from quantitative data, we see that they have really high rates of obesity and diabetes and high mortality rates. Well, wait a minute. Why do they think that they're healthy? What do they actually think health is? And maybe they're very happy having a wonderful family and having a good living situation, and maybe that's health to them. We can't really know until we talk to them. And also, if we want to understand a process or maybe a theory, again, we need qualitative methods where we collect stories and we observe people and we interpret this process that they're going through. So we've already alluded a little bit to correlation and causation, but quantitative research might provide correlational data where two variables tend to follow a pattern together. So for instance, as one goes up, the other variable goes up, or as one goes down, the other variable goes down, or maybe as one goes up, the other one always goes down, or vice versa. These are correlations, and these variables have some kind of relationship, but this isn't causation. So here you can see an interesting statistic. As ice cream consumption goes up, crime rates actually also go up. There's a positive correlation there. So wait, are we saying that ice cream causes crime or that crime causes us to eat more ice cream? Of course not. But they do evidently have some kind of relationship. So anytime you see correlation, you cannot assume one causes the other. Now, some theorize that ice cream consumption goes up when the weather is nice. And it's also easier to commit crimes when the weather is nicer. But we haven't even demonstrated that with this correlation. So next is causation. Now this is tough to demonstrate. And notice I didn't say tough to prove. We rarely use such strong language as prove in research. So in causation, we're demonstrating or supporting that an independent variable, an IV, caused a change in the DV, the dependent variable. So remember, we need experimental or quasi-experimental research to support causation. But in order to demonstrate causation, we need to show that the IV, the independent variable, happened before the DV. In order to cause it, something has to happen before the effect happens. And also that nothing else feasibly caused that change in the dependent variable. So this is where you need really nicely designed studies that we don't have a lot of interference and other noise, in a sense, in the study that could have caused a change in that dependent variable. So now there's the issue of multi-causality as well, where maybe multiple things are interacting to cause an outcome. So when we talk about causation, remember we need an experimental or a quasi-experimental design. Regardless of the design, we are including manipulation of an independent variable to see whether or not it affects a dependent variable or outcome. So a simple example, does the IV medication, so the independent variable or is a blood pressure med, cause an effect on the DV or the blood pressure? So what's the difference between quasi-experimental and experimental? Well, experimental is really the gold standard, and this is the best case scenario in true experimental studies, and sometimes these are called randomized controlled trials or randomized clinical trials. We call them RCTs. In these cases, the researchers have made sure we randomly assign participants to a control group and randomly assign participants to an intervention group. People don't get to pick their groups. Otherwise, I'm pretty sure we'd only have people who liked the intervention in the intervention group. So when we say randomization, we're saying that any single participant in that sample for that study has the same chance of being in the control group as the experimental group. It's up for grabs. It's random. And sometimes we do this by a simple coin toss. There's also computer programs. Now, quasi-experimental still includes an intervention, but we do not have a randomization for our participants. So we don't put them randomly into control groups and randomly into intervention groups, or we just don't have a control group. We just have an intervention group. Now, why would people do quasi-experimental studies then? Well, depending on what's being studied, it may not be feasible to have a control group, or it may not even be ethical to have a control group. Or maybe because of the type of intervention we're doing, you can't really randomly assign participants to a control group or an intervention group. Now, keep in mind there are some very high quality, well-designed quasi-experimental studies out there. So do not assume that just because it's quasi-experimental that it's a bad study. And there are very well-designed studies and very poorly designed studies of all types and categories of research. So that's why it's your job to really look closely at each study to determine if the study itself was designed well, not just if it was a good design because it fell into one of these categories. Next up, we have control and manipulation. So let's say you're conducting a study where you want to see if a stair climbing intervention affects participants' weights. Now, control is your ability to manipulate or control factors in your study that could get in the way of what you wanted to study. So, for example, you want to see if stair climbing affects weight. Well, with control, you could see what variables might affect weight besides stair climbing. So, for example, what if all the people in the stair climbing group happen to have a high metabolism? Or what if all the people in the control group happen to be avid runners? Those things could definitely affect weight. And then I wouldn't be able to see the effects of my stair climbing intervention. So to address this, I control or regulate or statistically adjust for those factors that could affect the dependent variable, the outcome variable. So to address this, I could control who's in which groups. I'm going to randomly assign people to the control group and randomly assign people to the intervention group. So the runners and the high metabolism people could be placed in whichever group randomly and not choose their group. Or maybe I could also see if the two groups have similar starting weights, and if there are major differences, I could account for that in my statistical analysis. Now, manipulation is your ability as the researcher to decide who gets on the stairs and who doesn't. You manipulate that independent variable. You decide who and how that intervention group will get that stair climbing intervention, and who and how the control group will not get the stair climbing intervention. So last here is extraneous and confounding variables. And we've already kind of alluded to this some, but these are those variables that get in the way or could inadvertently affect the dependent variable. So for example, if some participants have knee problems, they might hate this program and not do it, or they might have increased pain and stress because of it, and that could cause their weight to go up. I should probably not include participants with a history of knee problems. Now, keep in mind, sometimes we can control for those extraneous variables, like I mentioned here, by excluding those knee problem people. But there are always extraneous variables out there that we can't control for. And sometimes we don't even know that they exist or that they happened. So, for example, what if for whatever reason that control group happened to be waiting in the lobby before signing up for the study and saw a jazzercise infomercial? And suddenly they're all really intrigued and end up going to take jazzercise classes or do jazzercise videos at home while this study is going on. And they lose a bunch of weight. I didn't see that coming. I didn't know that was going to happen. Or maybe some new legislation is passed that reduces funding for public transportation, and my intervention group now has a harder time coming to my stair climbing classes. Again, keep in mind, there are always potential unforeseen circumstances that could affect the results of any study. And this is why we never say, this study proves blah, blah, blah. We might be aware of some of those confounders or extraneous variables and we account for them, but we might not. So no single study is perfect, but we try to design them as best we can to account for those pesky confounding variables. So I know this is a lot of information to take in, but the better you understand these concepts, the better you're going to understand the research you're reviewing in this course and also in your future practice. So keep a few things in mind. First of all, this is definitely not an exhaustive list of every possible type of quantitative design and every possible type of data collection. Researchers are very creative and they tend to combine things and even invent new methodologies. So when you read a study and you see an unfamiliar design or an unfamiliar type of data collection, you need to use your resources to look it up and learn a little bit more about it. Now, also when asking a PICO question, we are asking about the effects of an intervention, the I, on an outcome, the O. So can we answer a PICO question with cross-sectional research or descriptive research or correlational research? Well, not really, right? If we're asking about the effects of an intervention, we need to review intervention research. So you're going to be looking at quasi-experimental or experimental research or RCTs. Very rarely are there exceptions to that rule. Now, this is not to undervalue descriptive or correlational research or cross-sectional research. All of those studies are very, very valuable in building our nursing knowledge. But for the purposes of answering your very specific PICO question, you need a very specific type of study.